Okay, so hi everyone. Am I audible and visible to everyone? Okay, so starting today's session. So my name is Kajal and I've been working as a software engineer for around 6 years now. And in today's session, I'm gonna cover the microservices and the real real application. We'll take real life based application examples as well. Okay, so I'm gonna start it. First of all, let me share my screen. So, can anyone tell me if my screen is visible or not? Okay, okay, it's visible now. So, today we're gonna cover what exactly are the microservices, and we're gonna see some real world use cases of microservices. Okay. So, first of all, what are the topics that we're gonna cover during the class? So, first of all, what exactly is a monolithic service architecture? In order to understand what exactly is a microservice architecture, first of all, you have to understand what exactly is a monolithic architecture, and then what issues were there with the monolithic, and then how exactly we like we take the issues and we move to the microservice architecture. And then after, when we have a new architecture, there are some downsides of the microservice architecture as well. We're gonna see that downsides of the microservice architecture as well. Okay. And then after, we're going to see when to use microservice architecture. Okay. It's not always good to use microservice or monolithic. So we have some points on which we have to uh, take care. Okay, we're going to cover these points: when to use microservice and when to use monolithic. Okay. And then after, if you have some monolithic architecture, then how you can migrate from monolithic to microservices. Okay, so these steps of migration we're gonna cover in the class. And then after, we have some real world problem examples, like how exactly some top product based organizations moved from monolithic to microservices. Okay, so these all are the topics that we're gonna cover in today's session. Okay, can we move ahead? Okay, so first of all, in order to understand what exactly is a microservice, let's say you are a new business owner. Okay, and you want to make your own website. Okay, in order to increase your productivity, or in order to increase your sales, in order to people like know you more, you want your websites and you want to take orders from your website. Okay, so what do? What will be your thing to do? Will you see like how many microservices can I do break, or you will write some code so that your sales can increase? What will you do? Can you think? You can comment as well. Okay, so whenever you are new to a business, or whenever you are a new service owner, okay, and you are trying to make your own application, then you will start with a very very small code base. Okay, or with a very very happy flow code base. Okay, and for that, you will go with one service, you can say. In one service, you will have all the happy cases. Let's say a user will come to your homepage, and whatever he wants to do, he'll do. And then after, he can go to the cart page, or he can make some order, something like that. So you will only focus on the happy flow or happy cases in one microservice. Okay, or in one service. So that is a monolithic service. Whenever a business owner comes to a platform of online platform, he will see it as a complete as a one service. Okay, which is known as a monolithic service. Okay, that means whatever code base is written inside it is inside a one repository only. Okay, this is known as a monolithic service. Okay, and then after, when you are getting older, then all the new use cases are coming to your monolithic platform. okay, and your code base is getting increased. Okay, now you are seeing the new use cases are coming. Okay, so the code base is getting it bulkier. Okay, which leads to the microservices direction, which are taking you to the microservice direction. Okay, so what is monolithic? A large computer network with one code base, okay, that couples all the business concerns together in a single unit. So let's say this is one computer. Okay, this is one computer you have, or you can say it is a server. Is it visible now? uh, Whatever I'm writing. Yeah, yeah, you can post if you have any doubts in the comment section, or you can tell me like if the screen is visible to you or not. That all you can write in the comment section. Okay, so I'm assuming this is visible. So let's say you have a computer or a server, okay, and you want to write some code. Let's say you write down some code base, okay, and on the server, all the users which are coming to you, let's say you have multiple users. These are all are the users, or you can say user requests. Okay, so all these are the user requests that are coming onto your server. Okay, and your server is able to provide you an output. So output is getting generated. Okay, so if all the requests that are landing on your page, that are landing on your server, are getting successful output, in that case, why would you think of some another servers, right? You will not think of adding new servers or adding new things to your existing use case. Okay, but now let's say your users are increasing. Okay, I'm assuming now your users are getting increased. Okay, so earlier we had only 3 users, but now you can see we have multiple users. Okay, now this server which you had earlier is not able to give you the expected output. Okay, now you are not getting the expected output. Okay, so basically now you're not getting the expected output. Okay, in that case you will think like how you can improve your server, or how can you add some more servers to it, how can you divide the complete code base into multiple chunks, so that like you can get the expected output. So this is the uh, part on which it like the you think of the new things. Okay, and to the soul's creation for the code operation, I know C++, what should I learn and how to do projects. So for that, like we're gonna come later. For now you can ask questions related to microservices. We're gonna come on these things later on. Okay, so now one thing, in early 90s or in early 2000s, what do you think? People uh, did not have their internet on their mobile phones. Okay, people used to go on the cyber hubs for internet, for accessing internets. Okay, and people did not know how to use internet and how to serve internet. Okay, and how to go to some websites and check it. So the traffic on the websites was very very less. Okay, that's why, because the traffic was very less, so the monolithic architecture was the traditional way of doing the software development, because the traffic is very less and people were getting the expected output. Okay, so that's how it becomes the traditional way of doing the software development. Okay, it is convenient. Why it is convenient? Let's say if all the code base are written on this server, okay, you can see all code inside one server, so it is always easier to debug it because all the code is inside the one server. Now you can see what exactly this, like from where the function is getting called. Okay, so it is always easier to debug or to see what exactly is going on one server. Okay, so that's how it is convenient way of doing things. Single deployable or executable component. What do you mean by single deployable? So basically, if I want to take a release, okay, if I want to make some changes, what do you think? How many deployables I'll require for only one server, or let's say for only one repository? Only one deployable. So let's say if I make changes in one repository, all the changes will be reflected to the all the servers. Okay, so that means I don't need to take multiple executables. Okay, is it clear till here what exactly is a monolithic service architecture? Okay. I hope it is clear till here, and now we'll be moving ahead. And like, let's try to understand what exactly is a monolithic architecture first of all. Let's say if I have a monolithic architecture, okay, we have multiple clients, okay, which are coming to the e-commerce website that we have. Okay, we have a load balancer. So can anyone tell me what exactly a load balancer does? So a load balancer loads the client. Let's say we have three servers. Okay, it loads the clients to like each server, so that each server will have almost equal number of clients on it. Okay, this is the task of this load balancer. So now let's say we have multiple clients which are going to the e-commerce website, and we only have one repository. What do you mean by one repository? That means all the code base is inside one repo. That means, let's say the product page is visible through that repository. Let's say the service cart, let's say the carting system is also coming from the same repository. Discount service is also coming from the same repository. Okay, and the order service is also coming from the same repository. Yeah. So basically, all the data is inside the one microservice or inside the one repository. Now, what will happen? Let's say there is a bug inside this order service. Now, what do you think? How can I fix it? Basically, I'll do the code and all the services will get restarted. Okay. So, can you think like what do you think? Is it a good way? All the services will get impacted with a little bug in order service. Okay, or it's a single point of failure. Let's say if there is an error inside the discount service. Okay, so all the services are down because this service is not able to come up. Okay, so this is the problems with the microservice architecture. Is it clear till here? Okay, so now let's see what exactly were the issues with the monolithic architecture. In detail, what we can see is, first of all, a large code base. Because let's see if this is the repository in which I was writing all the code. Okay, I'm assuming this is the repository in which I am writing the code. A new requirements comes. Okay, a new requirements come from the product manager or someone, okay, who says to do some more functionality to it. What I'm going to do? Am I going to create a new microservice? No, I am not going to create a new microservices. Instead, what I'm going to do, i'm going to write I'm going to write the new requirement in the same repository only, in the same repo. Okay, so basically in this repository, I'm going to add new requirement, new code to the new requirement, and then again the process will goes on and on. Okay, so this repository will have a lot of code base now. So that's how the code base becomes larger. It is tough to understand because we have a lot of code base now. So it is difficult to understand what exactly we have written inside the code. Till the time the code base was very, very little, it was easier to understand. But now, because the code base is very, very vast and we have a lot of code, so now it is difficult to understand the code or the business logic, and hard to test. Let's say there is some bug, then we have to understand the complete service first of all, and then we have to test it. Okay, so and then we have a tightly coupling between the component as everything is inside the one application. So all the things are going inside this one repository. Okay, so all of them are tightly coupled. What do you mean by tightly coupled? That means if there is something wrong with one if there is something wrong with one service, then all the services are down. Okay, as I was talking about this. So let's say there is something wrong, or let's say there is something wrong happened in the discount service, then nothing will work. The product page will not shown up, the shopping cart service will be down, order service will be down, everything will be down. Okay, so basically these are tightly coupled with each other. Okay, so okay, so now if you know about this open close principle, so this is a principle that we have to follow whenever we are writing some code, which states that open for extension and close for modification. That means if there is a class, then it should be open for extension. There can be some extension to that class. We should not modify the class, but we should extend the class. Okay, but if all the code is inside the one microservices, then it is possible to follow the open close principle as well. Okay, because everything is inside the one code base, and we will try to complex it. We'll try to make it simple, but it will get complex. Okay, and then more deployment and restart times for even a small bug. So basically there will be more deployment. So let's say if you see this micro monolithic architecture, let's say I want to make a release for catalog service, let's say, then I'll have to take a release for everyone. Okay, if I want to make some changes in order service, then I'll have to take the release for everyone. Okay, so that means number of deployments will be greater, and restart times even for a small bug. Okay, and then it is less scalable. Why it is less scalable? Because let's say we have limited number of resources. Okay, we cannot scale it after an extent. Okay, so basically let's say if you're going to see this monolithic architecture, we have only one database. All the services are keeping the data inside this one database. Okay, and now this database will have a lot of things inside it. Okay, it is always difficult for to scale. Okay, in case of monolithic, and this services always become a single point of failure, because if there is something wrong with any one of the services, everything is gone. Okay, so these are some issues that we were facing with the monolithic architecture. Okay, so now moving ahead to microservice architecture. So what exactly is a microservice architecture? So basically splitting the complete application into some smaller and independent parts is known as microservice architecture. What exactly I mean by this? So if this was my repository, this rectangle is representing the complete repository. And if I divide, let's say if I divide this complete rectangle into multiple parts, let's say this, okay, and this. So what I did, I completely divided the complete repository into three different parts. Okay, and now this a like a big rectangle has been divided into three parts. Let's say one, this is two, and this is three. Okay, these three are nothing but what? These three are the microservices. Microservices. Okay, which contains the same code which was present in all the three microservices. Okay, this big repository was has the same code base as all of these three microservices have. But what is the difference? Difference is, so basically what we did, we divide it so that these three can be treated as an independent microservices. Okay, so this is the microservice architecture. Split the application into smaller and independent services. And now what is the advantages? So basically loosely coupled. What do you mean by loosely coupled? So let's say if I'm going to make changes in this one, let's say I'm going to make changes inside this. Okay, so I can write it like this. I'm gonna make changes inside one. So now this two and this three will remain unchangeable. So basically, we don't need to make changes in the two microservices and the third microservices, because now these are all independent. Okay, and we don't require to make changes in two and three. We only need to make changes in one. Now if let's say by any issue or by any bug or something, let's say this one service goes down, will it impact second or third service? No, it will not impact the second and the third service. Okay, the second and the third service will remain as it is. Okay, this is the microservice architecture. That's how these are loosely coupled architecture with independent deployables. What do you mean by deployables? So basically, deployables are the jars or the vars which we deploy on a server in order to reflect the new code base. Okay, so let's say this is a different repository, this is a different repository, 2 is a different repository, 3 is a different repository. So all of these will have different deployables. Okay, that means if I want to make some code changes, then this will have a different jar, this will have a different jar, and this will have a different jar altogether. Okay. Okay. So now the next thing is small teams will have their independent responsibilities. So now if you will see this, a huge rectangle box, which I was considering it as a repository, will have a lot of people working on the same code base. Okay, but now on the small boxes 1, 2, and 3, let's say we have three teams which are working independently. Let's say one team is working on the one repository, second team is working on the second repository, and the third team is working on the third repository. All the teams are working independently, they are not dependent upon each other, and they can have their different tasks to do. Okay, they are not dependent upon each other, so they can work individually. Okay, so small teams can have their independent responsibilities. Then after, easily scalable and no bottleneck of resources. So now what do you think? If let's say there is one database, this is the database with this microservice. Okay, so this is the database with this microservice, only one database. And now if you will see, there are three repositories, and let's say if these three repositories will have their own databases. Okay, this is the database 1, and this is the database 2, and this is the database 3. Okay, so now all the microservices have their own databases. What does it represent? That means we have a lot of things, like we have less burden on this database, and we can do a lot with them. Okay, so uh, so will not have the resource, uh, will not have the bottleneck on any resource. Okay, so this is what I mean. Okay, so now we can use different uh, tech stack. Okay, what I mean by this, so if I want to add some more functionality to the one repository, what do you think? Can I use different language? Can I use some different tech stack? No, because it was inside one repository, it has one environment. But as these three are working as an independent microservices, I can have this one microservices in Java. Okay, and this two microservices can in Python. Okay, and this three microservices can be in JavaScript. So it depends upon me what I want. Let's say I want to make my microservice in different language, that is possible. Okay, because these are not dependent upon each other. Okay, so this is possible only in the microservice architecture. It is not possible that in one repository I'm writing a code in Java, and for some another task I'm writing the code in Python. This is not possible now, because we have to set some environment of the project, right? So which is not possible inside one repository, but it is possible inside the microservice architecture. Okay, so we can have different tech stacks to achieve different business logics, which is achievable by the microservice architecture. So now we know, in the monolithic architecture, we have all the code base inside one repository. This is clear. And in the microservice architecture, we have in the in the monolithic architecture, we have one repository which have all the code base, and in the microservice architecture, we have different repositories which have different code base. Okay, this is what I know. But now the question arises: how can we break down the application? Now I know, if you want to see this, now I know this is the complete application. This big rectangle is a complete one application. How can I split this big rectangle into three boxes? So this is the question number 1 which comes to our mind. Okay, so this is one. Now next is what code goes where. So let's say it has 1,000 lines of code. I'm assuming this repository has 1,000 lines of code. So now the question comes, what line of code will go inside the one repository, what line of code will go into the second repository, and what line of code will go into the third repository. This is the question. Okay, how can I do this? Third is, how many services do I need to create? So how I'm thinking that with the big, with this one big rectangle, who decided that I'm gonna make three microservices? This is the question, right? I have one big monolithic service. How can I divide the big monolithic service into three microservices? Who gonna decide this? I can divide it into the four, or I can divide it into the two. Then why I'm dividing it into the three microservices? This is the question. Then how big and small microservices should be? So let's say I'm dividing the complete rectangle into these three microservices that I'm sure of. But this can also be the case that my one microservices has this much code base, and then my second microservices will have this much code base, and let's say my third will have this much code base. How I'm gonna decide, how I'm gonna decide which microservices will have how much code base? Okay, how I'm gonna decide it? So this is my third question. And last question is, how will the services communicate? So now what I did, I completely divided the microservices into um, microservices. Okay, one service I divided into multiple microservices. But now the question arises, how my microservices are going to connect with each other, how they're going to communicate with each other. This is the question. I think all the questions are clear. Do you have any more questions in your mind whenever you think how to convert your monolithic to microservice architecture? If you have any question, then you can write down in the comment section. Okay, so moving ahead with these questions only, and then if anyone will have more question, then we'll answer that. Okay, so what is the solution? Now I know that these all are the question, how I'm gonna break the application, and what exactly code goes where, how many services do I need to create, and how big and small services should be. Okay, so for all these questions, all the four questions, the answer is here. Okay, so basically we should split the complete application based on the business functionality. Okay, so first of all we have to understand what exactly is the business use case. Okay, let's say for e-commerce website, what do you think, what exactly is a business use case? So there should be some service which will show you the product page. Let's say if you go to some Mintra or some e-commerce website, so first of all you scroll. Okay, you have the catalog, or you have the product page, okay, on which you see the product. So this is one service, this is the one business logic. Okay, and then you have the shopping cart service. What exactly this shopping cart service will do? This gonna take the products from the product page to the shopping cart page. Okay, so this is the second functionality. You are creating an order with the products. Okay, you saw a product on the website, and then you want to purchase the product, and when you are purchasing the product, you are adding the product to the cart. This is the second functionality. Okay, and then the third one is you're making some payment. Okay, what does it mean? So that means whenever you have something in your cart, in your shopping cart, you want to make some payment and you want to purchase it. This is the third business use case. Okay, so we can have another use case, like a user wants to see the account. Let's say the user wants to see the user history, how many orders did he purchase for the 1 week or for the 1 month. and how exactly the user has put down the user detail. Let's say a user want to see the user phone number or the user address that he had put in his profile. So this is one use case. Okay, so what we did, we divided the complete use case into different functionalities. Okay, and then we split it into the different microservices. So how we're gonna divide it? We're gonna see the business use case and we're gonna split it into the multiple microservices. This is how we're gonna split it. Okay, so now how we can break down the application. What code goes where? So basically all the code related to payments will go inside the payment service. All the order creation logic will go inside the shopping cart service. All the product page, like how exactly my product page will look like, so all details like that will go in my product service. Okay, and user detail, like how exactly the user look likes on the user page will go inside the user account service. Okay, so this I know, like how I can break down the application. Now what I know is what code goes where. This is what I know. How many services do we create? So we do not have a specific number. Okay, this is not fixed that I need to create 3 microservices or I need to create 10 microservices. No, basis upon the business logic, what exactly we want to achieve and how many business logics we are covering, then after we can think of how many services do we need to create, then how big and small the services should be. So what do you think? All the user related code, user account related code should come into this, irrespective of how many line of codes are coming into it. Okay, so all the payment related thing will be going inside the payment service, irrespective of how many line of code I'm writing inside it. Okay, so I think it is clear till here. But one question is still remaining, which is how will the services communicate? How will the communication happen between the microservices? Okay, so uh, is it clear till here? Like we can we move ahead? Okay, I think we can move. So now we know, basis upon what exactly is my business requirement, I can split the application into different subparts. Okay, and now I also know there should be a separation of concern. That means the product service will only take care of the product page, or will only take care how exactly the product will look like on the website. Okay, and the shopping cart will only take care of how to create an order and what will be the amount of order, so something like that will be taken care by the shopping cart service. So there should be separation of concern. Every application should do its own task. Okay, the payment service will not take care of how much, like how exactly the order is getting created into the DB. Okay, so there should be a separation of concern. Then after, self-contained and independent. So that means the product should not dependent upon the user account service, or the product service should not be dependent upon payment service or something like that. So these services should not depend upon each other. Okay, so let's say if I want to make some changes in the product service, then I need to write the code inside the product service repository. I'll do the code and I'll push it to the production. That's it. Okay, it should not be dependent upon the shopping cart service, it should not be dependent upon the payment service or anything else. Okay, and all these will have their different deployables. The product will have their own jar, shopping cart will have their own jar, so every microservice will have its own jar. Okay, now the question arises, how will the microservices communicate? Okay, to understand the communication between these two, what I'm going to do, let's say I'm going to create this as a microservice 1. Okay, and let's say this is the microservice 2. Service 2. Code, there is some code written here. Okay, and some code written here. Okay, so now the repositories are different. Okay, but what do you think, what where exactly is the user? Let's say this is the user. Okay, Okay. Now user does not care about how many services do you have. Okay, this is upon you, like how many services you want to create. This is on the person who is maintaining it. Okay, and user wants to see the data, let's say, which is present inside this, and the user will also want to see the data which is present inside this microservice 2 and microservice 1. Okay, in order to get the data from both, these two microservices need to communicate. Okay, these two requires to communicate with each other. How will the communication happen? Okay, so there are multiple ways to communicate from one microservice to another microservice. What are those? So first is using the API calls. So let's say there will be an HTTP call. Okay, so this microservice one will make a HTTP call to this. And how exactly this HTTP call works? So basically we have an end route. Okay, and with this HTTP call and with the exact path, this microservice will be calling this microservice too. This is the one way. And this is the synchronous communication. What do you mean by synchronous communication? Synchronous means whenever this microservice gonna call the microservice 2, in that case this service will be waiting for the response from the microservice 2. Okay, once the response will come from microservice 2, the microservice 1 will listen it and it will move ahead. Okay, this is known as a synchronous communication, and it will wait for the response. This is the one way of communication from microservice 1 to microservice 2. Okay. Okay, so now what is the second way? Second way is using a message broker. What do you mean by message broker? So let's say in order to make a communication, what I'm gonna do is, let's say there is a queue. I'm gonna say it a queue. Okay, there is a queue which is passing the messages. Okay, to the microservice 2. Okay, so this is, let's say, the message one message, this is the second message which is getting passed, so something like that. So what is happening inside this microservice 1? Let's say there is something going on, let's say object creation is going on in microservice 1. Okay, and now we need to send a mail. Sending a mail is happening inside the microservice 2, let's say. Okay, once the order is done, it will it will send the mail using this. It will send it into the queue that please send the mail. Okay, and now the message is inside this queue. Okay, and when this microservice will read it, it will see I need to send a mail for this task. Okay, and the like sending a mail will be happening inside this microservice. In this case the communication will be asynchronous. This is not synchronous communication, this is a async. That means microservice 1 will not be taking care of what exactly is microservice 2 is doing, or it is doing or not doing. Okay, so it is just throwing the message inside this microservice 2. Okay, so this is the second way of communication. And we have third way of communication, which is using a service mesh. So service mesh is a way which we use with Kubernetes. Okay, and like in case of microservices, which is the like another way of communicating. So these are some ways through which we can communicate using the like between the two microservices. Okay. Okay, so moving ahead. So when you have microservice architecture, it is not always a good architecture. Okay, you have to see the requirement whether you need to move to the microservice architecture or not. Okay, it can be possible that you always require to stay on the monolithic architecture. It's not like कि monolithic architecture is always bad. Okay, and we should not follow द भीड़ कि भाई ठीक है सब लोग चल रहे हैं towards the microservices and I'm also going towards the microservices. First of all, try to understand, do you need to go to the microservice architecture? Yes or no? If you need to go to microservices, then only go to the microservices. So in this slide, we're going to see what are the downsides of using microservice architecture. Okay, So first of all is we always have to uh, configure the communication between the microservices. So now you see, we are making HTTP call, we are using this queue for the communication between the microservice 1 and microservice 2, or let's say we were using the service mesh or something like that. There is a way, okay? There is something that I'm looking for communicating from the microservice 1 to microservice 2. Okay, there I'm looking for some communication way. Was it required inside this? Like I did, if I want to call something, I'll call the method if it is inside one repository. Do I need HTTP methods, or do I need Kafka or RabbitMQ or something? Do I need service mesh? No, because all the code base was inside the one repository only. If in case I needed to call some method, I could call it by the method name. That's it. Okay, this all the communications way that I'm looking right now was not required in one repository. This is one. Okay, and let's say this microservice is not working appropriate. Okay, so if the microservice 2 is not working in an appropriate manner, then what will happen? Let's say if there is an HTTP call from microservice 1 to microservice 2, but microservice 2 is down, it will send some inappropriate response to the microservice 1. Okay, like microservice 1 was waiting for the response from microservice 2. Okay, in case of some issues, the microservice 2 will send some inappropriate response to microservice 1. Okay, so this is the one problem, or you can say a downside of using microservice architecture. Okay, second is in more difficult to monitor the multiple instances. So earlier, when you were using this one repository, you only had to deal with one repository. You only have to see, is my is my services up or not? Okay, is my application running or not? You only have to see one application at a time. But now, in order to see my application is running, you always have to see my all microservices are running or not. Okay, so this is the second thing. So more difficult to monitor with the multiple instances of each microservice. Okay, now third is redundant data is present at multiple places. Okay, so what exactly do you mean by redundant data is present in multiple places? See, if this microservice one requires some data, okay, it will keep the data inside one database. Okay, this is the database of one service. Okay, of one, let's say. So now it will keep the data inside it. Whatever data is required, it will keep it. And this service too will have its own database. Okay, let's say this is the database of two. Okay, now because both of the microservices have their own databases, which is database 1 and database 2. Okay, both have the different databases. Whatever data is required for this microservice, it will keep it inside this. Whatever data is required inside microservice 2, it will keep it inside this. But what if both require some common data? Okay, so let's say there is some common data which is required by both. So in case the common data will reside in both the databases, so the data will be present, the common data will be present here. Okay, and similarly the common data will be present here. So if the data is present in both the databases, that means the redundancy is there. We are keeping the data in two of the servers. Okay, which is this. Redundant data is present at the multiple places. Okay. Then there is something called breaking changes are present in the microservice architecture. What do you mean by breaking changes? Okay, I'll explain it. Let's say we have a function. Okay. Let's say return report. Okay, and I'm passing a report ID. Okay, and this is doing something. This is a method which is doing something basis upon the report ID, and this is returning a report, let's say a CSV report or something. Okay, but this is written inside one microservice. Okay, this is written, let's say, in microservice. Okay, and now let's say there is another microservices which is calling this return report. Okay, and let's say it is passing 10 or 11, whatever. It is inside microservice 2. Okay, and this is calling this method. Similarly, some other microservices there which is calling the same method. Let's say I'm copying this and I'm writing it over here. So let's say this is third, which is calling this again. Okay. So the implementation is written inside microservice 1, and microservice 2 and microservice 3 are calling this method. Now let's say due to some reasons I made some changes. What changes I did? I, let's say, instead of saying int, I am passing string report ID. Okay. Now instead of this, I'm passing it as a string report ID. But microservice 2 and microservice 3 are not aware of this. Will compiler tell us this is an error? No. Compiler will not tell us because it is not inside this microservice. If this code is written in some another microservice, compiler will not be able to check am I calling the right method or not. Okay, which is known as the breaking change. So this change is a breaking change. It will break the functionality from wherever it is getting called. Okay, so there are some chances of breaking changes in microservice architecture. Okay, then we have logging and debugging becomes a challenge. How logging and debugging becomes a challenge, can you think? Okay, thank you. So now, how logging and debugging becomes a challenge? Question comes over here. So let's say we have this microservice, we have this microservice, and this microservice. Okay, this is logging data. Let's say in server 1. This is logging data in server 2, and this is logging data in server 3. Okay, I'm placing an order. So first of all, it is going over here. This is the first place. This is the first microservices. This is the first microservice on which the order is going. And then after it is going to this second. This is the second microservice. And then after it is going to the third microservice. And now let's say all of the microservices are writing the logs inside some another service. Okay, these all are writing in some another servers. Okay, now how I'm gonna debug it? So first of all I need to see the logs on this server, then I'm going to see the logs on this server, then I'm going to see the logs on this server, to just to see where exactly the issue is happening. Okay, which is not possible. A developer will not go on all the servers and see where exactly is the issue. Okay, so debugging or the logging becomes a challenge. Okay, then after we have multiple tools available to tackle all the challenges that we face in a microservice architecture. Okay, so whatever I have explained, like whatever issues that I explained just now, we have different tools. Now if I want to go to some microservice architecture, we always have to read some another extra tools. Okay, now let's say you are new to the business and you want to create your website, and you are going with the microservice architecture. Then you have to do a lot. You have to see how exactly Kubernetes work, how exactly Kafka works, or let's say how exactly Kibana works. So you have to see a lot of things, okay, in order to make it work. Okay, So this is the issue with the microservice architecture. And so basically these are all are the topics that we discussed with the downsides of the microservice architecture. Okay, so now the question arises, when to use microservice? Okay, when microservices are good. What do you think? Let's say you have a team of 10 people new to the business, and you have only, or let's say you have 100 people. Okay, so do you think microservice architecture is good for you? So the microservice architecture will not be good in this case. Okay, but whenever you grow, okay, whenever you have a good team, or whenever you have good developers to understand what exactly things are going on, okay, nowadays, then you can move ahead with microservice. But if you have very small team, then small teams can take benefit from the consolidated code. What do you mean by consolidated code? One repository, or max to max two repository. Of, let's say you have 100 people, now let's say 50 people are working on one repository and 50 are working on second one, which is okay, which is not bad. Okay, but you have only four people in your team, in your development team, and you have three microservices, which is not good, na? So first of all, whenever your team grows, then you can move to microservice, otherwise you should not. Okay, so this is one. Clear communication and documentation is required. What do you mean by this? I explained this issue. Yeah, this one. So instead of integer, I'm taking report ID as a string. Okay, so if the communication is not clear, if this communication is not clear between the microservice 1, microservice 2 and 3, then there will be a case of failure. So if you are using microservices, then there should be a clear communication and documentation which is required. Okay, whenever you need to go from microservice architecture, because compiler is not aware on the break changes, compiler not sure what exactly you're writing inside your client or your service. Okay, you have to take care of it. And then third, and the major thing is, duplicacy is not a big problem for your case. That means, whenever you are dealing with the microservice architecture, there will be duplicacy of data, of code, or everything. Okay, if that is not a problem for your case, then you can go with the microservice architecture. Okay, so what we have learned till now, it's not always it's not always ki we the monolith architecture is always good, or microservice architecture is always bad. Okay, it's not like that. You have to first think nicely or carefully, that do I need to move to microservice, or do I need to keep on keep the monolithic architecture. Okay, so now let's say, now that you have to move to the microservice architecture. You made a decision that I was using monolithic architecture, but I now want to migrate to microservice. Okay, so now what are the ways to migrate from monolithic to microservice architecture? I'm going to explain that. Okay, so in order to go from monolith to microservice, uh, so in order to migrate from monolith to microservice architecture, uh, first of all, what I'm going to do is, let's say this is my monolith architecture. Monolith architecture. Okay, and some lines of code are here. Lines of code is here. Okay, so line of code is present in the monolithic architecture, but I want to break the complete architecture into microservice architecture. Okay, let's say, first of all, let's say I have a redirection logic. Redirection logic. What do you mean by redirection logic? First of all, so let's say my request is coming to this microservice monolithic architecture. First of all, I'll redirect the request to microservice. Okay, so let's say I have some redirection logic. Let's say I write down for all the order IDs, which order IDs which have one at the end call this HTTP request. Okay, so now what will happen? Let's say the order IDs which have at the end 01, or let's say which will have 11, 21, 31, 31. Okay, so all these orders will make a HTTP call, and this HTTP call, what will this HTTP call will do? This HTTP call will take your request to my new code. Okay, this is my microservice code. Microservice service code base. Okay, and uh, instead of doing this code, like whatever code was written was written in monolith, I'm executing the code which is writing inside the microservice. Executing the code inside executing the code inside the microservice. Okay, so now I am doing the same task what exactly this monolithic architecture was doing. Okay, in this manner I'm gonna test my code as well. Okay, so now after some time, what I can do, I can redirect all the orders to this microservice, and later on this monolith architecture will not even required to me. Okay, so for the user will directly come to this microservice, it will not go to this monolithic architecture. Okay, then the redirection logic will not be required anymore. Why I'm writing this redirection logic? Because I want to test my code first. I want to see, is my microservice code is doing exactly same what the monolithic architecture is doing. Okay, so the idea is whatever output I was getting from monolith, I'm getting same from the microservice. Then why I'm breaking the monolith to microservice? Because now I know I have 1 million user on my monolith, and with the same speed after 6 months or so, I'm gonna get 2 million users. Okay, when I'll have 2 million users, I will not able to serve 2 million users from the monolithic architecture. At that time I'll require the microservice architecture, and that's why I'm writing this code base. Okay, is it clear why I'm writing this microservice? Okay, so just to answer Deepak's question, we have a lot of good books for the microservices. Okay, but you can also go through some good documentation. I'll share you the link at the end of this lecture. Okay, so moving to the topic. So first of all, what I did, I redirected some order IDs to my microservice code, and later on, when I had confidence that my microservice is exactly doing the same thing what my monolithic is doing, I'll push all the requests to my microservice code base. Okay, so this is the first way. We write down the new microservice code and migrate 1% traffic first to test the new code. So now we need the older code base. Okay, let's say I want to make some change. Okay, in that case I need to make changes in my monolithic architecture, I need to make changes in my microservice, and let's say if there is some changes, then I need to make changes in the redirection logic as well. Okay, so this is a lot of engineering effort. Okay, so this is a drawback of this. Okay, and again we have to monitor both this monolith architecture. I'll need to monitor if this is working fine or not. Also I'll need to monitor microservice code base till the time all the requests are redirected to the microservice code. Okay, uh, Zomato is doing this kind of thing. So earlier Zomato was written on PHP. Okay, and it has a monolithic architecture, and now they are doing this, they are redirecting some percent of their traffic to the new microservice code base. Okay, okay, and the second way is, let's say our application is in the development phase. Okay, the requirement is coming. Okay, now let's say a new requirement came, a business requirement, a new business requirement comes. Okay. Now, in case of a new business requirement, what I'm going to do, I'm instead of writing the same, like the new code into the same code base, I'm going to write it into the different repository. I'm going to create a new repository for the new requirement. Or let's say sending mail, let's say sending email or SMS. Okay, this is one feature which is required by multiple services or microservices. Okay, for this, I'm going to do is I'm going to create a new microservice, and just to move this simple code, this mail, sending mail or SMS code into the new microservice. And after that, from wherever this was getting called, from where we were sending the email, instead of doing via code, I'm gonna call the new microservice. So what I'm gonna do is, let's say new things are coming into the development phase. So first of all, I'm gonna see where exactly I can put it. Okay, in which repository I can put it, and then I'm creating a new repository and doing the code inside the new repository. This is the second way. Okay, so now let's say, for an example, let's say one task comes, analytics. Okay, so let's say some tasks comes, and now the service owner wants to see some analysis, like where exactly the user is dropping off. Okay, you are let's say an owner of e-commerce website, and e-commerce website owner wants some analysis. So in order to write some